The following is the video solution from JSDT Solutions. Question 4 says, the lines y equals x plus 1 and y equals negative x plus 3 are the axes of symmetry of the function, and this is g of x. Also notice that they have made this value positive, but we know that it's supposed to be x minus p, so just remember what to do with that. And 4.1 says, show that p equals negative 1 and q equals 2. Okay, so with this and with what they've given you the axes of symmetry. Okay, both of them. That axis of symmetry, the one with a positive gradient, okay, that's why the gradient there is positive. And they gave you the one with a negative gradient. There's something you need to know about the axis of symmetry of a hyperbola. They intersect, but their point of intersection is specifically at the point of intersection of your vertical and horizontal asymptote. Okay, so here is the full picture. Okay, let's say we have this hyperbola. We might as well just work with it, where the value of a is less than 0. If a is less than 0, it means that your graphs lie in the second and the fourth quadrant. Okay, so you see, that's an axis of symmetry. It cuts the graph symmetrically. That's another axis of symmetry. It also cuts the graph symmetrically. That looks exactly like that. Likewise, this part looks exactly like this part. That's what it means to cut it symmetrically or divide it. So ultimately what happens is these two lines, the axis of symmetry that we have, they intersect at that point of intersection of your asymptotes. So that would mean whatever x value they have, and I think it's just best to actually draw a y-axis. Okay, so let's say the y-axis was over here, right? And let's say the x-axis was just here. It doesn't actually look like that. I'm just putting this here as an example. So that would mean the x value that we have here of that point of intersection, that is that x value that belongs to your vertical asymptote. Okay, that x equals p, that is that. And then the y value of that point of intersection is the y value that belongs to that horizontal asymptote, that y equals q. Now, please note that they have said x plus p, so just keep that in mind. Okay, so since we know it's a common point of intersection, we know how to find p and q. It's that point of intersection, meaning equate your graphs. Okay, it's the point where both graphs are equal. So we'll simply say y equals y, and we're saying x plus 1 equals negative x plus 3. Then transpose. This will become a positive x, so x plus x is 2x equals 3, and then transpose the 1 minus 1 is 2. Therefore, if you divide both hand sides by 2, x equals 1. Now, what this means, x equals 1, this is our p value. This p value specifically, this is 1. You know that the original equation of a hyperbola, here where it says x plus p, it's supposed to say x minus p. So when we input this in here, we would say x minus 1. So what does that mean about their p value, the p value they've given us here? It means that this p is negative 1, okay? Because you can only get x minus 1 by saying x plus negative 1. So that is the value of p. And so we can tell them that p is therefore equal to negative 1. And then we still have to find q. So since the x value was 1, to find the corresponding y value, you take this x value and you substitute it into either one of the graphs because they both intersect at this point. So they have the same y value at this point. So we can simply say y is equal to, and we'll say 1. Okay, we're using this x value, but you still need to tell them what their p is. So we'll say 1 plus 1 using this equation. And so y is equal to 2. And so this means that q is equal to 2. And that is our answer. P equals negative 1, while q is equal to 2. And moving on to the next question. Question 4.2 says, calculate the x-intercept of g. Okay, we have the full equation of g now. We can just rewrite it. So g of x is equal to negative 4 over x minus 1 plus 2. And so to find the x-intercept, we simply make y equal to 0. So 0 equals this. And you see, in this case, you don't really have to transpose the 2. This is already negative in the numerator, so let's transpose it. And now it becomes positive 4 over x minus 1. Nothing happens to the denominator. Transposing it, this negative belongs to the full fraction. It was just sitting in the numerator. And then this is equal to 2. And now we can go ahead and cross multiply. So if you make this a fraction, to make it a fraction, you can put it over 1. Then now that it's a fraction, you can cross multiply. So this is 2 multiplied by x, which is 2x, and 2 multiplied by negative 1, which is negative 2, is equal to 4. And we can transpose the negative 2. So 2x equals, we have 4 plus 2, which is 6, and divide both hand sides by 2, and x is equal to 3. And that is the x-intercept. X equals 3. You can leave it like this because they didn't really say calculate the coordinates of the x-intercept. So that is our answer. Moving on to the next question. Question 4.3 says, sketch the graph of G in your answer book, clearly showing the asymptotes and the intercepts with the axes. Okay, so this is a hyperbola. Let's point out the things that we need and just write down the steps we need to take. So step 1, you need to have your asymptotes, okay? If you draw your asymptotes down first, it makes it easier to sketch this graph. So we know our asymptotes, okay, from this whole discussion. We know that x is equal to 1, okay? Clearly shouldn't be this side. X is equal to 1, and then y is equal to 2. So that's the horizontal, that's the vertical. So we know these now. X equals 1 and y equals 2. The second thing you need to put down are your intercepts with the axes. So you need to put down your x-intercept, which we have. It's 3. So as a coordinate, this is 3 and 0. And then your y-intercept. Now I just noticed this is actually something we don't have. So we need to find this. Okay. So we'll take this equation of the graph, and it's a y-intercept. So to find a y-intercept, you simply have to make x equal to 0. Okay, so in place of x, we'll just say g of 0, and then there's x, replace 0. And this would be, you see, that will give us negative 1. Negative 4 divided by negative 1 is positive 4, plus 2 is 6. So g of 0 is equal to 6. And now we know that our y-intercept is simply just 0 as the x value and 6 as the y value. Okay, so we have our intercepts. That's step 2. Then step 3 is you need to know the shape of your graph so that you know where to draw them. Okay, so our graph has a negative a value. If a is less than 0, remember that your graph is going to lie in the second and the fourth quadrant. Okay, so let's get sketching. So with the graph, just draw down a simple Cartesian plane. Make sure to label your x and your y axes. So now that we have that, the second step would be draw the asymptotes, really the first step. Okay, you need to always make sure you have your asymptotes down so you know where to not go beyond. So x equals 1. This is a vertical line. So we're going to draw a vertical line. Make sure that it's dotted at x equals 1. Just show that it passes 1, and this is x equals 1. And then we need our horizontal asymptote at y equals 2. So this is a horizontal line passing 2. And then make sure that it is also dotted. Y equals 2 over there. Then next we're going to put down our intercepts. So that is 3 and 0. Okay, so relative to what we have here. If this is 1, then 3 is way over here. Okay, so this is 3 and 0. You can put it as 3 and 0. And then we have a y-intercept of 0 and 6. So we can just go up and say, okay, this is 0 and 6 that we have over there. Okay, and then once those points are down, just remember that your graph is going to lie in the second and the fourth quadrant. So it's going to look something like this. So you need to make sure that it passes this point, right? So it's moving closer and closer to that asymptote from here. So we're going to move up and move closer and closer, and it just never touches it. And then on this side, we're simply just going from here and we're moving closer and closer. We cut through that x-axis, and then there we go. So there's our graph, and you can just label it. This is the graph of G. And that is our answer. Moving on to the next question. Question 4.4 says, for which values of x is g of x greater than 0? Okay, so looking at g of x, where is it greater than 0? This refers to the y values of g. Okay, g of x means y equals mx plus c. You could also say g of x equals mx plus c. So where are the y values of this graph greater than 0? Where are they positive? We know that we have positive y values over here on the y-axis and then negative y values over here. So that would mean that the graph where it will have positive y values would be all the places where the graph lies above the x-axis. You see that everything here has positive y values. This point over here, positive y value. That point, a positive y value. Even these ones, those have positive y values. So everything above the x-axis has a positive y value, and you're just going to select those and then tell them the values of x for which these parts of the graph exist. So if you line these down to the x-axis, look at where these are. These are values that are, where do they start from? You can see that because it's all through here. Okay, we can't just start from here. We don't know what number this is here. And this graph is going to keep going and get closer and closer to that asymptote. So it will still have positive y values, meaning you need to start from over here. Okay, so it's not exactly at 1 because we have an asymptote there, but it's values that are less than 1. So immediately less than 1 and then all through like that. The graph will always have y values that are greater than 0. So we got that one part. X is less than 1. And then on this side, we also have a selected piece of graph. So if you line this down to the x-axis, do you see that the point where it starts is immediately after this x value of 3. So it's values that are greater than 3. We can't really say equal to 3 in this case because at 3, you have a y value of 0. And they only said they want y values greater than 0, not equal to 0. Okay, so this will be x is greater than 3. So those are our answers. We can simply tell them x is less than 1 or x is greater than 3. And those are our answers. And that is it for question 4.